And we'll talk about the radio horizon and some of the space weather phenomena. When you're doing VHF, UHF, with handy talkies, repeaters, basically you're doing line of sight, assuming there's no buildings or mountains or whatever in between where you can possibly get reflections or knife edge diffraction and all that stuff you learned in the technician and the general classes. The formula that they use for line of sight is basically, we calculate the radius of the Earth and a height above it, and then a chord to where that intersects or is tangent, and comes out with this formula that it's the square root of the height in feet times this 1.21 number. So if your handy-talkie is 5 feet, the square root of 5, whatever that is, times 1.2 will tell you how many miles it is to the horizon. And if somebody else has got their handy-talkie 5 feet, it's another, whatever that is, distance. So you get twice that. In the case of radio horizon, where you actually get some bending of the path, it's basically the square root of 2 times that square root of the height. So you get about 15% more distance due to the curvature than if you calculated straight line of sight. How does the VHF, UHF radio horizon compare to the geographic horizon? Okay, prediction techniques. There's things like reverse beacon, which you can look up and will give you indications where you see the beacons, and they transmit, there's beacons all over the Earth, and they transmit on different frequencies at different times. So you can see what the propagation is on those different bands from different directions. PSK reporter is another one. I'm not sure if there's a phone app. There probably is. You can get it on a laptop. And they keep track of CW and digital stations that report to it. And they keep a plot of those signal paths. It's very similar when I showed you the balloon tracks. And that's doing a thing with Whisper, which kind of works the same way. And there's apps that track Whisper contacts. There's a software package, which I can't say I've ever used, called vocap, because it was developed by the Voice of America. I'm not even sure if that's still a thing. Is it?
Yeah, it's good.
And they have this vocap software that will model HF propagation. So what type of data is reported by amateur radio propagation reporting networks? Delta? What does vocap software model? HF propagation.
Gives you a nice wheel.
Huh?
It gives you a nice propagation wheel once you put in all the parameters. And it gives you the time around it, and then the bands as you go in, and it provides the color of how likely it is to make
Cool.
contact. Yeah, it's really nice.
Maybe I'll have to go look that up and put a chart in for next time.
Okay.
Um, do you remember the A and the K indexes? I'm pretty sure they talked about them a little bit in the general, where they look at the geomagnetic activity from the sun. And as I remember, the A index is one where it's averaged over a 24-hour period, and the K index, they do it every 3 hours. And they're measures of how much the sun is disrupting our geomagnetic field.
These can feel pretty good, but sometimes it's like surprising you. You'll have like last weekend, the K was up there, the A was I think I don't know 4 or something like that. I'm thinking that's gonna be kind of not real great. It was killer last weekend. I mean, when we were doing that side bend contest, and I mean we were killing it on 20, 15, well, it was so light on 40, so it was. This is way better than I expected based on the. So that's not always it.
Right.
It doesn't surprise me.
I didn't turn my email off. So the higher those are, the more it affects the paths along the pole, because they're going to have much higher levels of absorption because of the extra radiation. So they behave more like the lower E layer and F layer and absorb signals. So what is indicated by a rising A or K index? Increasing disruption. Which of the following signal paths is most likely to experience high levels of absorption when the A or K is elevated? Anybody?
Right. Henry Follow says polar.
The way they did that answer made it confusing. There's also the B sub Z, which is used to represent the strength and direction of the magnetic field. So it goes along latitude lines.
And the QRZ site, they've got the chart, and I've actually been looking at it for
Yeah.
It's kind of helpful now that I know what a lot of that stuff means.
So it's basically trying to tell you the likelihood that the incoming particles from the sun, which would be a CME, massive ejection, is going to cause disturbed conditions. If it's going southward. If it's going northward, I guess it's good. I don't really understand it. I've never looked into it. So you know more about it than I do.
Angles, it's kind of, it's not going to be to the north, it's on
Form of
the south. Like,
Okay.
you know, it went
So maybe north is the reference.
north pole is the property.
So I guess when it's directly south, that's not good. What does the value of B sub Z represent? And then even there, it's north to south strength. So that's the direction it's going. What orientation of B sub Z increases the likelihood that charged particles from the sun will cause disturbed conditions? So,
Remember do that today. I'm glad she left on easier stuff.
space weather. Uh, it's really sun activity. Solar flares will produce a lot of radiation, gamma rays, ultraviolet rays, uh, infrared, all that. And those will actually ionize the ionosphere. And the stronger those things are, the deeper the ionization goes. So the right amount is good, too much is bad, like a lot of things.
Years ago, a station in Shreveport, the space when they had the space weather squadron out there, and they did a lot of all this predicting for the Air Force. But I remember telling them, I'm like, how hard is that job? It's cold and dark. I mean, every day.
So like I said, when it's just the right amount, you get the maximum propagation because you're not getting the absorption effect in the lower layers. And usually if the propagation is poor, it's because we've had a lot of solar flare activity. What is the cause of short-term radio blackouts?
It's interesting. Well,
Huh?
it's the answer is delta. But, I mean, I guess why isn't it alpha? Is it because those cause a more prolonged blackout?
The CMEs affect the magnetic field. I mean, that's called geomagnetic storms.
But it's not a blackout condition, it's just impacted here.
Let's see, was there anything about that here? Because they only talked about radiation, not CMEs, which would make you think the answer is delta. We'll see. It is. I guess because
Because the question is short term.
yeah, actually, coronal mass ejections can definitely cause a blackout.
Isn't CNE solar flares?
No, CME is actual holes open up in the surface and it ejects matter.
Yeah, explodes out.
Where the solar flares, you're getting radiation. Okay, ultraviolet, gamma. And the CME, you're actually getting particles, electrons and positrons. So it's actually matter, and that's why it takes. See, that's one of the general questions. How many days does it take to get here? Or 20 hours, right?
Yes, somewhere.
And it's 8 minutes if it's a flare. If I remember right. You could calculate it if you know how far the sun is. Which of the following is indicated by a sudden rise in radio background noise across a large portion of the HF spectrum?
So that's sort of an key question. You get more noise, your noise floor comes off if it CME where you don't necessarily get black.
Yeah, CMEs, I mean, we were lucky back this previous one that it missed us. If it had been a direct hit, it would have been one of the most significant ones. We would have had power grid probably going down in a lot of places. Communications would have been out.
What's there one in the 1800s that was so significant that like telegraph wires, column wires, and stuff like that? Like I remember,
Yeah,
reading about that.
yeah.
It's
Any conductor is going to get. Okay, so we categorize solar flares by intensity, and there's class A through class X. Usually they don't talk about A. They usually do C, M, or X. X is bad. And in each one of those classes, they range from 1 to 9. It's kind of like the hurricane scale or something. And I think each level is 50% more than the previous one. So this shows for a C class, 1 through 9, they're considered small, not much effect. An M class can cause some radio blackouts and interference. An X class can take the planet-wide radio out, and I think also mess up power grid and stuff like that. Although it's mostly affects electromagnetic waves. Which of the following indicates the greatest solar flare intensity? An X. An X9, I guess we're in deep doo-doo. NOAA has come up with their own scale called the G scale, which indicates the geomagnetic conditions. And it goes from, I believe, 1 to 5, where G5 is an extreme geomagnetic storm. Maybe what we would have seen if it actually had, that CME had hit us. For a 5, it says widespread voltage control problems and things on power systems. Affects spacecraft. Wow. Currents of hundreds of amps and really bad stuff. Where G1 is kind of minor. You might see the effect, but it's not going to do any real damage. Which of the following is the space weather term for an extreme geomagnetic storm?
Okay.
They also watch sunspots. The more sunspots, the better, I believe. Not exactly sure why, but it also has an effect on where they are as the sun's rotating relative to us, or we're rotating relative to it. So if there's a bunch of them going away from us, we don't see the effect as much as if they're starting and coming towards us as it rotates. They use this 304A parameter because they measure ultraviolet, which is the 304 angstrom wavelength. And they correlate that to the solar flux index. So that, and since the ultraviolet is one of the main causes of ionizing the F2, the upper F layer, F2 layer, that's why they look at the UV emissions. So what does the 304A solar parameter measure?